Okay, good morning everyone. Today we are going to continue on. We'll be working in section 5.5. Today we'll be looking at the complex number set. Just when you got the hang of the real number set, which includes the rational and irrational numbers, we will introduce the complex number set. So our objective today will define and use imaginary and complex numbers. Principally, we'll perform addition and multiplication of complex numbers. And then the vocabulary: imaginary unit, imaginary number, complex number, real part, imaginary part, and complex conjugate. We'll do more with complex conjugate tomorrow when we actually start to solve quadratic equations. I will say this though, okay, the imaginary numbers are just that. They were imagined. And so they were imagined about this at the same time as electricity was discovered. Because when folks were working with electricity and trying to solve equations, they kept running into a problem, and that problem was they would get a negative underneath the radical, like a -3. Okay? Now, there's no real number where you can take the square root of a negative number. There's no real number. In other words, there's no number you can multiply by itself and get a negative. None. A negative times a negative is a positive, and a positive times a positive is a positive. Okay, so you can't take the square root of a negative number. But nonetheless, they had to deal with that, and so they came up with what's called imaginary numbers to be able to solve equations. So today we learned about the imaginary number system. So all along we've been working with quadratics, and we've been finding the zeros. And so we've been finding the zeros. So for example, maybe we had a quadratic that looked like this here, and across the x-axis there, and the point at which across the x-axis we had y is equal to 0, so we found the zeros. Or maybe rather than crossing it, just touch. So maybe something like that. You know, that was a perfect square trinomial, right? But nonetheless, it touched the x-axis. We still had real numbers in each case. Okay, now we'll be working with quadratics that won't cross or touch the x-axis. Okay, so like the example they show here. And when we have that situation, we will have a negative underneath the radical. We'll have imaginary answers, imaginary roots. Okay, so the way folks got around the problem of having negatives underneath the radical is that they created this imaginary unit called I. And they defined I to equal the square root of -1. The square root of -1. Now again, there's no number that when multiplied by itself will give you negative. Okay, think about that. What number multiplied by itself will give you a negative? There isn't one. Okay, but what they said, we'll imagine that there is one, and we'll just call it I. All right. So the two important points here is that we have to keep these two things in mind. One, we'll say I is equal to the square root of -1. That's one thing, and then we'll say I squared is equal to -1. All right, so this is going to be important. It'll be important for this chapter and the next chapter. We'll be working with imaginary roots a lot. Okay, so I is equal to the square root of -1, and I squared equals -1. All right, so let's look at the complex number system. So a complex number is a number that can be written in the form of a plus bi. A plus bi, where a is the real part, where a and b are real numbers, and I equals the square root of -1. A and b are real numbers, and I equals the square root of -1. The set of real numbers is a subset of the set of complex numbers. Likewise, the set of imaginary numbers is a subset of the set of complex numbers. Now, to recall, the real numbers are the rationals, those things that we can write as a fraction, and then those things we can't, the irrationals. But now we'll have imaginary numbers, purely imaginary. So I, 3i, negative 5i, the square root of negative 7, which you'll just say is I root 7. Okay? But both the real number set and the imaginary number set are subsets of the complex number system. Every complex number has a real part and an imaginary part. Okay, I've asterisked that. I'll say every complex number. So for a complex number to be a complex number, it has to have a real part and an imaginary part. If it has just a real part, we just say it's a real number. If it has just an imaginary part, we just say it's an imaginary number. But if it has a real part and an imaginary part, we'll say it's a complex number. So negative 2 minus 3i would be a complex number because it has both a real part and an imaginary part. A number like negative 5 belongs to the real number set in the complex number set. Okay? So as you can see, real numbers are a subset of the complex numbers set. But negative 5 is not a complex number because it doesn't have an imaginary part. A number like 2i belongs to the imaginary set in the complex number set, but it is not a complex number because it doesn't have a real part. But a number like negative 5 plus 2i belongs only to the complex number set, only. Not the real number set because we have an imaginary number, and not the imaginary number set because we have a real number. It belongs only to the complex number set. So again, just to reiterate, a number like negative 5 belongs to the real number set in the complex number set. A number like 2i belongs to the imaginary set in the complex number set, but a number like negative 5 plus 2i belongs only to the complex number set. We would say that's a complex number, not the real number set because we have an imaginary number, and not the imaginary number set because we have a real number. So again, key point, a complex number must have a real part and an imaginary part. If it doesn't, it's either a real number or an imaginary number. However, it still belongs to the complex number set. It's just not a complex number. Again, every complex number has a real part and an imaginary part. All right, so now let's look at operations, and this is pretty easy. To add and subtract complex numbers, we add the real part and the imaginary part. So here we have 2 plus 5i plus a negative 5 minus 3i. So we add the real part, so this is going to be 2 plus negative 5 plus 5i plus negative 3i. We have a 2 plus negative 5 plus a 5i plus negative 3i. Or 2 minus 5, which is negative 3, plus 5i minus 3i, which is 2i. Okay, so answer. Done. Add the real part and the imaginary part. When we have subtraction, we have to change subtraction. We have to distribute the negative. Right? So this would be, so what we'll have here, we'll have, so I'll change, so I'll have a plus, so this would be a plus negative 5, and then distribute that negative, and then we'll have a positive 3i. All right, plus negative 5, and then a positive 3i. So then we'll add, so we'll have 7 minus 2i plus negative 5 plus 3i. Oops. Yep. And so we'll add the real part and the imaginary part. So we'll have 7. So minus 5, if you will, or plus negative 5, however you want to look at it. 7 plus negative 5, and then plus negative 2i plus 3i. And so that will give us 2. So that will equal 2 And then what's that? Plus I. 7 minus 5 is 2. Negative 2I plus 3I is I. Okay, 7 minus 5 is 2, and negative 2I minus a negative 3I, or is I. Negative 2 plus 3. Negative 2I plus 3I. All right, so 2 plus I. Add the real part, add the imaginary part. Now, when we multiply complex numbers, we must remember that I squared is equal to negative 1. So here I have an example, 2I times 3I, 2 times 3 is 6, and I times I is I squared, I times I is I squared, but I squared is equal to negative 1, so 6I squared is equal to negative 6. We have negative 4I times I, so we have a negative 4I squared, but I squared is negative 1, so negative 4 times negative 1 equals 4. Again, key point, remember I squared is equal to negative 1. Have to remember that. I squared equals negative 1. And then we can FOIL. 2 times 4 is 8. And then 2 times 3I is 6I. And then negative 7I times 4 is negative 28I. And then negative 7I times a positive 3I is a negative 21I squared. We combine our like terms. 6 minus 28 gives me negative 22I. So we have 8 minus negative 22I minus 21I squared, but I squared is negative 1. And so we have 8 minus 22I plus 21. And then finally we have 29 minus 22I. And we always write in A plus BI form. The real part first and the imaginary part. Okay, so that's an introduction into the imaginary number system. Get used to it. We're going to be working with that for the remainder of Chapter 5 and all of Chapter 6. Okay, extensively in Chapter 6. All right, so that's just an introduction. And then tomorrow we'll be solving equations, quadratic equations, where we'll have imaginary roots. We'll get that pesky negative underneath the radical. All right, which will kind of, to be honest with you, will kind of make checking your work pretty difficult. Again, on decimals, because decimals will never give you imaginary roots, I don't think. You'll never be able to get them. See, if I go up here, oh, where was that graph? Oh, right there. Imagine trying to find the zeros on that. There are none. Okay. Hey, that's a happy face. You see that? Draw a little eye. Okay. Well, actually, it will be a sad face because you won't be able to use decimals to find a zero. So, anyway, I guess unless I find a way to do that, but I don't think you can, because there are no zeros, no real zeros. Anyway, we have imaginary zeros, imaginary roots. Anyway, what you guys are going to do, you will have a lesson out on what's that? Hope McDougall online. And now I finally got access to it, so let me show you how you guys will access that. And I'll put out the assignment tonight. And then you'll have to do it. Now I have actually visibility to see what you do. I can see here how many you got wrong and how many you got right. And then I'll just use that to put in a grade book there. So you get a chance to do things over and over again. But anyway, the way you'll access that, so you'll click on the class link for Hope McDougall Online. And that will bring, you'll click on that. And then that will bring you to my class link page, and then you'll click on Hope McDougall Online, and this will be the first time I'm doing this and assigning you some work. When you've done this before, I didn't assign anything to you. Well, I did, but it wasn't a true assignment. Now I can actually create an assignment, and then when you open this up, it should be ready for you. We'll see here come tomorrow. Anyway, some things have changed, so when you go to log into this, you'll have to log in with your student ID and your student password. Okay, so if you had created a password, remember we did this, if you had created a password that was not your student password, it's now going to be your student password. So anyway, so if you have difficulties accessing that, let me know. But I'll put out a lesson. And I think I'm going to use this for the remainder of these 2 weeks. So we only have 2 more weeks. So maybe even put tests out here and quizzes. Anyway, so that is it there for the lesson today. So pretty easy. All right.